Hi everyone, today we'll look at Linux shell scripting. Linux shell scripting. So what is it? So shell script is a text file. So it is a text file. It is a plain text file, okay? Containing a series of Linux commands. So it has a series of Linux commands that will be executed in the order of that series. On our Raspberry Pi, we'll look at particularly on bash shell scripting. Okay. So basically, in the shell scripting, the variables needs to be defined and used. Okay. So we can define variable like this: name equals, and then if it is a string, within double quote. And then in Linux script, if you do not know for sure, then I recommend you to put everything in one, no space in between. Name, no space, equal, no space, double quote, John, double quotes. When you use this, then you need to use $sign. Okay. When there is a $sign, then the label after this $sign will be evaluated. Okay. So when you execute this shell script, echo is the Linux command, and then it expects the following. That is a string. String will be echoed, but when it comes to $sign, then it the variables after $sign needs to be evaluated and go back to see if there is anything held in that variable. Okay. So we'll look at now here $sign followed by parenthesis, curly brace, and square brackets. First of all, square bracket, that is deprecated. It was used for arithmetic expression. Therefore, we have $sign 2 plus 3 square brackets, then it'll be evaluated. So instead of having this square bracket, then we use $sign and parenthesis. $sign and parenthesis, then you look at the variable within that. So evaluate that variable. Okay? It's one variable. So $sign x, then evaluate x and substitute it. $sign and curly brace, then a little more expansions. One single x, then evaluate it. So in this case, if you have one variable, then could be parenthesis, could be curly brace. Let's say x is a variable. If there is a prefix, pound sign, then we call that the length of x. Okay, and then the variable colon minus and whatever followed by, then first x is evaluated. If there is an x, then x is returned. If x is empty, then y will be the default value. Okay, this is a little bit complicated logics is in this simple expression. And x and double caret, then it'll be turned to the uppercase. And x colon a number colon another number, then x is evaluated, and whatever that x holds, let's say that is a string, then we extract substring. Okay, so starting from that number, it is counting from 0, 1, 2, 3, and then L for length. Okay, so that is what it is. So let's take a look at that. By the way, I'm going to push this a little aside. Well, I'm going to, okay. What I am going to do, reduce this a little bit, and then I think I need to put like this, and okay, perfect. So let's try to make a directory mkdir April 28. Okay, already exists. So we do cd apr 28. So nothing there. So first to try to see if let's say variable dot sf, I mean shell sh. Okay, let's make it nano variable 1 dot sh shell. So we create let's say x is Mercy University, and we can say echo dollar x echo dollar within that parenthesis echo dollar sign and curly brace x. See what we have here. All right, so that I can do save, Control O, save it, and cd John Noon, cd April 28th, ls, we have one variable. The way that we can execute this, look here, ls minus l, then there is a simple plain text files, right? So we need to make this executable using change mode. I want to add executable x to variable 1.sh files. Then look at this, ls minus x. Then we have x privileges, execute privileges added, right? Okay, now we can execute it. If we simply say variable 1.sh, then there's no command found. So we need to specify where that is. So if it is a current, that file, that shell file is in the current directory, then we can say dot for current directory. Within the current directory, vir1. So we specify the location of that file. By having this, your bash shall recognize which file that it should execute. So execute it. Therefore, Okay, so first one here, it says Mercy University, line 5. So 0. Let's see if we can put some line locations. Go to line here. Control /5, I guess. Control /5, then we know what that is. That is this, right? One. So command not found, line 5, echo dollar, that this is actually substitutions here. Evaluate that and it will be substituted. So this is an error, as it says. And then finally, this $sign within the curly brace, then it understands that, right? So if you want to use this, then you need to do, let's say, y equals, there's a substitute, and then you can say echo and $y. In that way, it should work, right? So, like this. Anyway, so again, as I said, the better way that you to do is, not only that, remember that this $sign, whatever inside that should be evaluated, but X here, it is not evaluated. $X will be evaluated, but X is not evaluated. So to make it a little better, I want to see something that can be, that is a command in the bash shell. I would say date. Okay, date is something that you can get. For example, if I say date, then we can see that. So I want to get, so dollar within the parenthesis date, then date is evaluated, and then it can be assigned to y, and then y will be echoed. Okay, so when I do this, then I can see here the first one, echo Mercy University, and the second one is another echo $y. Y is replaced with the $sign and date. So date is evaluated and assigned to y. So y is known, therefore it can be evaluated. And echo within curly brace, that we know. So we'll look at a little more than that. Let's say echo and then dollar and $sign X. Okay, and save it. How many characters are that X? That is what it is. So it has 16 characters, okay, at Mercy University itself. And then the other one is replace. Let's say echo dollar, and then we say if y is there, then we can say we write it. Otherwise, we can say cybersecurity. Okay. So if y is there, then it will be written. If y is not there, then instead cybersecurity. Oh, y over there. So y, because y is there, y is written. Okay, so y is already defined. We want to say Z, if it is Z there, okay? So, of course, Z is not there, so we say cybersecurity, okay? That's what it is. And then uppercase, echo, and X, I want to put that all caret, uppercase. All right, and then save it. Then Mercy University, all uppercases. The other one is substring. So echo dollar and X. I want to start it from third character. From the third character in that string X, I want to extract 3 characters starting from the third position. Okay, so I can get it. Then this is 0, 1, 2, which is all. From all, 3 characters. So we will have RCY. Okay, that's what it is. Okay, and then basic shell script like this. I believe we already had this, right? This itself is called shebang, okay? Which means that is the world, okay? There's a whole world of this shell script. So first thing here, echo whatever the entire string, that will be echoed. And then next one is name equals John. So this is a variable name. Name variable has the value John. So echo welcome $name. Then the labels after $sign will be evaluated. So your bash shell looking at if it holds the variable name. So here name. So evaluate that, which means get the value from that variable and return. That is it, right? So, okay. So we need to exit that, and then we need to make another nano, and let's say shebang.sh, and then I will copy and paste to this. Copy and paste. Okay. And then save it. What you need to do here, shebang.sh is a different color, right? Of course, this is executable, but this is not executable. So what you need to do, we need to change the mode. I want to give the execute privilege to shebang.sh. After that, /shebang.sh, then we can run that. So it says, hello, Raspberry Pi, welcome John, right? Okay, So this is how we used it. We need to first change the mode and then execute it. That's what it is. Okay. And we can add more if, else, FI block. So control blocks. Okay, so I want to nano shebang. Oh, I need to do Control C. We already have here, right? I want to add this there. Okay. So we have a control statements. If name, this is name variable name. If name equals John, then we echo hello John. If it is not John. And then the conditional block start with the if and ending with the fi. Okay. So I want to save this, and if I execute it, then it says welcome John, because it says welcome John, right? So what I want to do, probably I don't need this, right? Oops. If it's John, right? So we can say, hello, John. Let's say if it is John, two ends. Save this. Then it says not John, right? Not like the previous executions. Here, both works. Right. What's the difference? What it means here. I believe this still works. So what I meant by here is still works, right? Save this. Works fine. And also do this. Even if you don't have that, I believe it should work as well. Yes, that's what it is. Okay, save this. Okay, so creating and running script. Once you make a file, myscript.sh, then you need to give privileges of executions, and then you can run on the current directory / and then shell file. Loop is also possible. So we will make a another file, nano loop dot shell, and then I can say we can make a shebang. So £, exclamation mark, bin, and bash. Find for I in 1.5, and then we can say do and echo number $I, and then done. It should work, right? So we can do save this, and then when I do this, then loop shell is not executable right now, so we need to do chmod plus x2 loop.sh, and then loop.sh. We run it, and it says line 3. Oh, it should be curly braces, right? Not this, curly brace. So save this, and then run. Then we have number 1, 2, 3, 4, 5. Okay, and then we can do even more. Oh, okay. Now we want to combine together. Remember that previously we had let me copy this and show it to you what it meant. Okay, and here, so we define a set, variable set. Okay, I would say this is not just a variable, but define variable set or variable list that can be listed by, for example, there's no comma in between, but the parenthesis here, open and close parenthesis, we list the strings with no delimiter. Okay, and then in the loop, actually what it is this is a name, right? That is defined, and by having this square bracket at sign, then we can look at each index in that set, and then this $sign and curly brace. In this way, whatever $sign within curly brace, that will be evaluated. So it goes to names. If we do not have this, then we look at only one. By having this square bracket at sign, it goes at each cycle, each iteration, you look at one at a time. So one element at a time, considering all within that set. That's what it means. Okay, and then if this is for loop and do and done within this for loop, then we have if conditional statements. This conditional statements is the same as before, right? Because this name, pick each element in this list. That is kind of defining this variable. So in order to use this variable, then we need to put here $sign name, right? If $sign name is same as John, then we can say welcome doctor, and then that $sign name. Otherwise, not John, but whatever that is. If it is not John, maybe James, maybe Peter, maybe something else, right? That's what it meant. So we save this and try to run it. So run it. Then we can say this is the first 5. That's the same as before. Here, first element here, John. So welcome, Dr. John. Next is James. So it is not John, but James. Next one is Peter, not John, but Peter, right? So if we go, say, here, Ellen, save, and rerun that. We can say, not John, but Ellen. Okay? And I said here some of the comments. What if you have, you have to do this very carefully. If you say this, then whatever inside $, whatever that is quote, then after $, it wants to evaluate it. In the case, simply that is it, right? So you need to put this outside here. Okay. Or you can do simply without this. That is also possible. I believe it is possible. Let's see. Control. Yeah, that's possible. But if you do not have this, then it evaluates only names above here, first one, and it doesn't treat as a everything, I believe. So what it does is only John, and then this literally as is. This goes with the curly brace. So we need to do this. Then it goes with the curly brace. Therefore, it goes together. Right? So a little bit of a trick here, but that's what it is. So lesson, quote variable, quote $, this, prevent issues with the space. What happens is that why you need to quote here. Remember that as I said, one time I put here quote and unquote. This time I didn't use that. The difference between using quote or not using quote, that is if it is the case where there is like this. So prevent the white space. In order to do that, then we need to do quote for safety, right? So in this case, better to have this quote. That way, this guy, so all makes a little more. Previously, it has a red, this in red color, right? Red color means a little bit of warning, although it is not error. And this within a square bracket at sign, it goes for looping over all array elements. That's what it is. Okay. There's a language. Language is nothing but the symbolic agreement. So okay. So reading file is also possible. I want to have a file like this. So I want to have nano. It's called the name, right? Names.txt, and then we can say John, James, Peter, Sam, Ellen, David, and then we exit it. Then we have names.txt file, right? So I want to read the data from here within using the for loop. Okay, so I would say reading data from a file. So what we want to do, we want to use while read minus all name. Name is a local variable, and do the following until done. Okay, what we want to do here is echo, and then welcome in loop, and then we can say $name. That's what we declared this name, right? And then we need to say what is the input file. Then we can say names.txt. That is the file here. Names.txt goes into that. Okay. And I want to save this and try to run that. Oh, nice. So welcome. Oh, welcome in. Welcome in loop. Welcome in loop. The first John, James, Peter, Sam, Ellen, David, right? That's what we have here. What do you mean by here minus R? That I explained this. For example, if we have, let's say, the reading from the file to avoid the unwanted interpretation of a backslash. If there's a backslash, then for example, we have here, oops, sorry. Okay. Nano data, not data. Names.txt. I would say name is not simply let's say variable backslash yun, okay, something like that. And save this, and if I run that, then I want to still keep that backslash, but if I do not have this, if there's no minus options, then I have here all backslash will be discarded. Okay, so if I want to run it as is, then we need to have a minus all. Backslash is a escape characters, right? So if escape character is needs to be activated, then we need to use with the minus all, with no minus all option. Okay. Okay, and command subs. Yeah, that's what we looked at already, right? $sign and date. And then real world examples, checking disk usages. Let's try to get it. Save this. Did we change this? No. Okay, so nano and check usages. SH, and then I want to copy and paste it, and I will explain that to you. What it does here, I want to first save this, and let's take a look how it goes. So execute to that, and then run it. So disk usage is 78%. So what it happens right now, this is simply echo, right? Disk usage is $sign usages. So this usage is defined here. Usage is nothing but $sign within that parenthesis. So this will be substitute. Within that parenthesis, there is a, this will be evaluated within the parenthesis, df minus h, this is evaluated. Okay, I believe this, everything. So if I copy this, there's a command, right? And paste here. Oops, no, not everything. No, I want to. No. What I want to do is df minus h and slash, then 78%, right? And then if I want to do AWK, number of row equals to 2, so it's row number 2. I want to print row number 2 and print $5 means this is $1, 2, 3, 4, 5. So $5, I want to print that one only here. Therefore, I want to make a pipe here, right? Then only 78%. This will be picked up because of this, right? Line number equals 2, because it gives me the column title followed by the real data this is real data, right? In for each column. So I want to pick the fifth columns. That's what it is. And then if usage is greater than 90%, then we make here warnings. Why I have this? So I want to do to make a delete. I don't need this, right? If I want to, for example, over 70%, to see if it gives me some warning signs. Okay, so I want to run it. Yeah, that one. Okay, it says almost warning, disk almost full, right? So current disk usage is 78%, warning disk almost full, because according to this rule, usage is over 70%, then almost full. But that is not the case, so we simply... Okay. What if we want to do timestamp? A particular date we want to see. So I want to do here usage at as of and then dollar, and then we can say date. Okay. Then as of current date. It'll be, it says disk space is 78% as of Monday, April 21st, whatever that, okay? And then checking internet connection. So I want to make a copy of this, see how it works. So again here, paste, and then save this and run. And it says there's online, right? ping -c1 google.com. It means send one ICMP packet. So one packet. ICMP is, I think that is the internet configuration management protocol, connection management protocol, something like that. Packets to google.com to check connectivity. So we give ping the packets. And then if we have here ampersand and greater than sign, then both the output and error messages from this ping command will go to this /db/null, which means it doesn't print to the standard output, but it goes into that null device, which means the error messages and output messages will not be displayed. Rather than, and then we have an echo sign here, echo online or offline. Okay, so If ping succeed, then we can say online. If there is an error, offline. That's what it is. So it says online, right? What if we have here google.com dot, for example, JP, Japan. I believe that is, I'm not sure. Probably not there, right? So maybe offline. So if I run this, then offline, because there is no such things available. Okay, next one is display system information. So I can do only also this, copy and paste here. So this is a play system info and paste. Echo hostname colon. Remember that host name, then it gives us the host name. This is the command, right? So dollar within parentheses, then within parentheses that will be evaluated. So uptime is another command, right? And then free minus h, that is another command. So we can get the memory space. And then df, we already looked at this, right? So what is the percentage of that? Usages. So by having this, then we can say host name is Raspberry Pi, uptime is 8 hours 48 minutes, and memory usages, and then disk MMC block 0P2 117 gigabytes, 78% full, right? Okay. Backup directory. So we can make also backup. Here I want to do backup a directory. So when I do copy and paste of those, so source variable is a path expression to documents, and destination is another variable. I want to save it in my home directory, and then this is a file. I want to make a tar, this is a file name, okay? This file name is starting with the backup underscore, and then dollar date. This, we put the date stamp, and then plus %f means, watch this, if I do date and plus %f, it gives me that date only, okay? So if I say date and %f underscore, for example, hour, then I can see there's a 21 hour. And then again, if I want to do %minutes, then 9:35. So 21 means 9:35. Look at here, there's a 9:35 here, right? Monday, April 21, 9:35. That's what this exactly we have. So this is nothing but command, Linux command. So I want to put that as a part of the file name. So backup underscore timestamp dot tar dot gz. So this is this tar means a tar file, tape archive file, gzip. This is a compressed files. And then actually what I do is this is tar is a command minus czf. I want to compress the zip files. The file name is the destination is this $dest, and then source is $src. Remember, in this case, if I don't put here quote, then I may put, it may have some unwanted white spaces right after this destination. Okay, what if we have $gz and space? Then we may have sometimes a big trouble, because I assume that there's a extension is a gz, unknowing that there's a gz and space, right? That is it's not really a big problem, but time consuming to check that out. So to avoid that, we better put here quote and unquote. Quote and unquote is not technically, it's not really critical, but that may be that kind of unwanted the problems to happen. Okay, and finally we can say that is created. So let's try to do that, and so do this. Oh, I need to do save, right? To save this. Okay. Now, okay. So that is backup is created. All right. So what I am trying to do is to, I'll bring up another here to see if there is a home directory. Yes, there is a backup file, right? S-L. That is now created, right? April 21st to 2142. There's a 2043. If you want to do unzip it, then you first do gzip. So what you need to do is gzip minus d and backup that one, gzip. Therefore you have tar files, so tar and then xvf. You need to extract, right, rather than C, but X, and then backup that tar. Okay, so that is extracted. Okay. Combine the two of the previous script. So what it does is, let me close that, and Nano a little bit complicated. So I want to do what it does. Okay, let me back up disk.shell, and then I want to copy and paste here to explain that. Okay, this is a backup what we had so far, right? Oh, this is a, okay. This is a backup. Oh, we make directory, backup directory. We want to make a backup directory, backups, right? That's a backup directory under home and pi. What I want to do here, I want to a backup recently modified files. So remember that we have a find from the directory, whatever that we want to do, okay? From the source directory, from the documents directory, I want to see the file only. If a file's modification time is less than whatever this dates, because we have a minus and then days, we need to enter the dates. This is 1 day, right? And then pipe here, we want to tar it by compress and zip. This is the file, zip file that we want to create. Because this is a pipe, whatever returned from this find will be tarred and zipped. Okay. And I explained that in the following slide. Oh, I don't have that. Oh, there's not that yet. So if I explain that, a little more. Okay, so this printed 0 means it print result separated by null character. That is important to file name with the space tab and special characters. So we want to print that file name with the null characters. And then when you do tar, then we accept a null separated input from this find command. So this find command that will return the output. That output has it is separated by null character, which is \0. And when we take that as an input to this tar files, we accept that once. So minus null means we want to accept null separated input files, and that input files will be tarred and zipped, and it'll be saved into these output files. Okay, that's what it is. So what else that we need to do? Okay, so what we need to do here, we have a backups directory already here. Let's say what is there. Backups. So right now there's nothing in that backup directory. But by running these files, then we want to save backup files within that directory, backups directory. So I want to save this. And then when I come back here, then backup disk, that one is not executable. So chmod +X to backup disk. Now we have that is also possible to that. So backup disk to run it, then it'll be backed up. So when I come back here and ls backups directory, then I see that once that's created, right? 2150 tar and gzips. Okay, I believe this is it. So many things can be done by having this kind of a sequence of Linux commands under one command. Under one command. Actually, there is a command, right? There is executable, right? That is Linux script, shell script things. So Linux shell script. Remember that I think very early in this semester we looked at the Linux command is nothing but a program, right? So we created a program using Python so that it could be a command. And today we looked at by using such commands in certain order, put them in one file, then that will be another command, another Linux command that is nothing but Linux shell scripts, script files. It is very handy. You can do so complicated steps that you could do manually, but automatically by having one command executions. All right, that's what I want to say to you. All right, thank you so much. Bye.